So I think so common factors count can be 0 at the beginning, and then for individually for A and B I can try to find out. It would be for num in range 1 comma yeah, so 1 comma int of a to the power of 0.5 plus 1. So I'll say that okay, if a modulo num is equivalent to 0, in that case I'll say my first factor is num and my second factor is a by num. I'll say that okay, if my first factor is not equivalent to second factor, in that case I'll add it to a set. Or better I can do is, instead of doing that, I can say common dot add first factor and then common dot add second factor. That's done. This is for the number a. Now I'll loop here in the same way. So for num in range 1 till int of p to the power of 0.5 plus 1. So here I'll say that okay, if my b modulo number is equivalent to 0, then that means that okay, I have a first factor which is num and I have a second factor which is p by num. Now here I can say that if my first factor is not equivalent to second factor, in that case I'll say I'll say that okay, if my first factor in common factors list, in that case answer plus equivalent to 1. If my second factor in common factors list, in that case again answer plus equivalent to 1. Else I need to check for only one number. That could be done here only, right? Can be done outside itself. That's it. And I can return the answer. I could also try my best to pair this here. Yeah. So let's run this thing. We have a runtime error, answer reference before assignment. Okay, so it's not really answer, but it's common factors, right? So common factors, answer is 4 for this one. Let's submit this. Got accepted. Maximize sum of an hourglass. Maximize sum of an hourglass. You are given an mn2n integer matrix grid. We define an hourglass as a part of the matrix with the following form: A, B, C, D, E, F, G. Return the maximum sum of the elements of an hourglass. Note that an hourglass cannot be rotated and must be entirely contained within the matrix. So the hourglass can be of, okay, so it's in this format, right? So what I can do here is I can say that if I'm at a particular point, then what are all the possible cells I need to check. So if I'm at 0 comma 0, then I have to check that. So there's no increment or decrement in that. I can go 1 towards the right, so that's 0 and 1. I can go 1 towards the right again, so that's 0, 2. Now I need to check the diagonal, that will be 1, 1. I need to check the one below the diagonal, it's 1, 1, 2, 1. I need to check 2 below me, so 0, 1, 1, 0, 2, 0. I need to check the right hand corner, that's going to be 2, 2. 2, 2. So how many cells are there right now? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. 7 cells, right? Yes. And now I can just simply loop here in the grid, or I can even say max sum is initially 0. So for row in range, let's indeed define the number of rows as length of grid, and then let's define the number of columns as length of grid of 0. Now for row in rows and for column in columns, current x is row, current y is col. Now for I comma j, no, yeah, we can have I comma j, but let's say this can be x1, this can be y1. So I can say that, okay, for x2 comma y2 in probably possible, I can say my new x is nothing but x1 plus x2. My new y is possibly y1 plus y2. Now I'll check that, okay, if the current new x and new y is valid or not. So for it to be valid, I can simply have this small condition less than the number of rows, and 0 is less than equivalent to new y is less than the number of columns. I hope so the spelling is not wrong. And yeah, I think so, that's it. This is the only thing I need to see right now. And I think so I do need to have a temporary sum here, so I can say temp sum is 0. And once that's true, I can say that, okay, temp sum plus equivalent to whatever this is, so grid of new x, new y. Else I can probably say flag is equal to 1 and then break. So what this will ensure is to make sure to not consider this one, right? So else I'm saying flag is equal to 1 and then break. So at end of the day, I'll say that, okay, if flag, which means it's not possible to create an hourglass, or if not flag, then I know that it's possible to create an hourglass. In that case, my max sum is the maximum of max sum and whatever my temporary sum is. And I think so I can return max sum. It's running fine, 54. That is wrong, right? Okay, I can just do that. 6213 and Oh, so this temp sum won't be really initialized here, and this flag won't be really initialized here, but I think so it should be initialized here. So flag and then temp sum is going to be 0 and 0, right? Then it could possibly give me the answers 30 and 35. Yeah, 30 and 35. Let's submit this. Accepted. Okay. Minimize or given two positive integers num1 and num2, find the integer x such that my mom called me. Okay, given two positive integers num1 and num2, find the integer x such that x has the same number of set bits as num2. Set bits means what? The value is 1, right? So let's say number 2 is 5. So 5 has how many set bits? 2 set bits. So 101, right? So 2 set bits. Okay. X has the, okay, so given two positive integers num1 and num2, find the integer x such that x has the same number of set bits as num2 and the value of x XOR num1 is minimal. The value of x XOR num1. So XOR, what does XOR do? Right, the XOR is the bitwise XOR operation. Return the integer x. The disk is generated such that x is uniquely determined. So it's definitely unique than num1 and num2. Return the integer x. The number of set bits of an integer is the number of ones in its binary representation. And bitwise XOR. So XOR mein what used to happen was, if it's different, then it's kind of fine, right? So it's more like 1 or 0 would probably give me 1, and 0 or 1 would give me this. But like if I do a 0 or 0, that will be 0. 1 or 1 will be again a 0. So if the bits are different, then it's 1. And also the value of x XOR num1 is minimal, but like x should be having the same number of set bits as num2. So I think so this is more like 3 and 5, right? So in this case 3 and 5. So 3 is represented as 1 1, 5 is represented as 1 0 1, right? So this has like 2 bits. So what if I place the bits here and this turns out to be zeros, right? Then this will be some value followed by this 1 1, and this will be very maximum value, right? So I will try my best to put ones wherein in this representation ones are present. So I put 1 here because there is 1 1. I put 1 here because there's 1 1. So this XOR gives me a value 0, which is the minimum I can get, and this 1 1 is also the x value. So x is also 3 here. So let's say 1 and 12. So let's clear this example. 1 and 12, right? So 1 and then 12. So 1 is represented as this, and 12 is represented as how? What is 12? 8. No. 8, 4, 2, and yes. Huh. So 1, 2, 3, 4, 5, 3, 4, 5. Okay. 6. Yeah, 6. Okay. So I know that here I need 2 bits. So what can I do? I can put 1 1 here because there's 1 1 here, and then Definitely I'll put 1 here, because I could have even put oh my god, what happened? So I could have even put this one here, but this will become 1 0 0 0 0, which is 16. I don't want that, right? So in that case, I'll put a 1 just next to the recent 0, so that the value is minimized. Or if there was a 1 here, I would have gone here and simply put a 1 there, so that would have become 0, and then so on. So this value is x is again 3, but like the XOR is how much is the XOR value here? It's 2, right? Binary representation of number 3 has the same number of bits. The value of XOR is 2 is minimal. Okay, so what if I had a number, binary representation number like this, and I need to fill up, let's say 5, not 5, let's say, why is this not working? Let's say 4 bits or 4 set bits. So how will I create this? Maybe the idea could be to go from here, because that will reduce the number, right? So maybe I'll put 1 first here. Then the 0 can be really skipped. This 1 can be put here. Skipped. 1 can be put here. 1 can be put here. And like 4 ones are used. So this becomes 0, 0. If I do a XOR, 0, 0, 0, 0. 1, 1 is again 0. 1, 1 is again 0. And this is 0. So this becomes 1. So right now, my XOR value is 1, but like x value is quite huge here, right? So that does not matter. X could be very huge, but I need to just minimize x XOR num1. That's it. So maybe I can possibly say, so what's my binary representation of binary of num1 is, let's say it's going to be binary of num1. Again, I'm doing using something which is available in Python already, and the number 1 can be 10 to the power 9, which is quite good here, because binary of, let's say, 10 to the power 9, oh my bad, and if I slice it, that should give me this value, which is, to do it again, yeah, that's not even close to that. So yeah, so 30 32 could be the number here. So I can simply say that, okay, if length of binary num1 is less than equivalent to, do I need to really do that? No, I don't need to. So I can simply say again here, binary num1 is going to be a little bit of zeros padded here. And how many zeros should be precisely there? There should be probably, let's say, 30 zeros are there, and I need 2 more zeros. What's the formula? 32 minus the length of whatever my binary num1 is, plus whatever my binary num1 was. That's it. So this is what my binary representation of number 1 looks like, and it's precisely 32 of them. Now I need to count the number of set bits in num2. That could be done using Brian Kernighan's algorithm. I really want to do that, but I don't remember the formula exactly, so I will see here. Let's say number is 4. So how do I see that how many bits are there in there? So let's say bits count as 0. I say while n bits count increases by 1. Oh, my bad. So I say bits count increases by 1, and I also say n I'll left shift it by 1, right? Or I will left shift this by this. Towards right. If I left it towards left, then a 0 will be added. So n is equivalent to n shifted by 1. And then, but this is not going to give me the answer, right? So if I print bits 3, right, which is wrong. In 4 there are not 3 bits, but I could probably modify this to work it like this. So while n, if n and 1, then in that case bits plus equivalent to 1, but I also do a right shift by 1. So right now bits count should be 2. Bits count is 3 still. So what's my n value though? N is 0, right? And what if I do something like that? Okay, let's say n is 5, and then I write the same algorithm again. Hmm. Hmm. Now bits count is 5. Or I could go the traditional way again. So set bits is how much? It's going to be simply L dot count that thing, right? So I'll say list of binary of num2, but I'll slice it dot count the number of ones. That's it. As the set bits. So now I can say my x number, right? So I can even say x number or anything else, but like x number kind of looks fine. Yeah, that could be 0 for I in range 32. Now I'll say while set bits or for idx in range 32 indeed. So I'll go from 0 and then so on. So for idx in range 32, if binary num1 is binary num1 of idx is equivalent to 1, in that case I am going to say that okay, x of idx is going to be 1, but there's a catch here. I'll probably add in something like and set bits it's greater than 0, but if it's greater than 0 then it will also decrease, and end of the day I can say that in my x number, right, I can say my new number is going to be I'll just simply join this thing back. So join of x number, but what I'll also do is I'll just simply return an integer of my new number comma 2. So but let's use the example test cases and run the code. 3 and 1, which is wrong, right? Because 1 and 12 should probably end up giving me a very big value, but let's see. So in 12, I think so there are a lot of set bits, precisely 2 of them. Yeah. And then I'm saying that, okay, if in binary, if the binary num1 of IDX is 1 and set bits is, so like by force, I have to probably form that thing, right? Okay. So there's a catch here. The case where 1 and 12 is there, right? So the case where 1 and 12 is there, what's happening is I'm forming like 32 zeros and then 1. In 12, I know that there is the representation is like this. So set bits is, I guess, 2. So what's happening here is it's coming to 1 and yeah, it's coming to 1 and I know that the XOR will be very minimum, but set bits count is remaining as 1, right? I have to put this 1 somewhere, else that won't really make sense. So the only place I think so will be that will be sensible to places. So when will I run out? So the case here is that I'll run out of all the bits and I still have set bits remaining. So when I still have set bits remaining, what I could possibly do is loop from the back here and try to fill up the set bits where the zero thing is there, right? Yeah. So I can probably say here that, okay, for IDX in range 32 or 31 till minus 1 till minus 1. So that's going to go from 31 till the very end. If my binary num1 of IDX is equivalent to 0 and set bits is greater than 0, then in that case as well set bits minus equivalent to 1, and I think so in X number as well at the current IDX it's going to be set to 1, correct? And I think so this should probably work. Let's run this thing. 3 and 3, let's submit the code. It's accepted. 1 hour 1 minute 35 seconds left. Okay, let's see maximum deletions on a string. So in this case I think so this is more like greedy method, right? Starting say initialize all of them by ones and then wherever there is 0 go from the back and do that, then it will work because this is an edge case. 3 done. Maximum deletions on a string. Maximum deletions on a string. You are given a string S consisting of only lowercase English letters. You are given a string S consisting of only lowercase English letters. In one operation, you can delete the entire string S. Interesting. Or delete the first I letters of S. Let's say first 3 or 2 letters of S. If the first I letters of S are equal to the following I letters in S. Oh, so they are following a pattern. For any I in the range 1, gonna be till 1 so it's equal to S dot length by 2. Delete the first, let's say 2 letters of S if the first 2 letters of S are equal to the following 2 letters in S. For example, if S is equal to ABC, then in one operation you could delete the first 2 letters of S to get ABC. Since the first 2 letters of S and the following 2 letters of S are both equal to AB. So it's not like it should be continuously equal, but only twice, right? It deletes the first I letters of S if the first, let's say 2 letters of S are equal to the following 2 letters in S. Or maybe I could be wrong here. Let's see. Return the maximum number of operations needed to delete all of S. Okay. Return the maximum number of operations needed to delete all of S. S length could be 10 to the power 5. It's 4000. I can think of brute force, but no, it won't matter here. So ABC, ABC, D, ABC. So I think so ABC can be deleted, then ABC, D, ABC. So it's saying 2. Why? Delete the first three letters ABC since the next three letters are equal. Now S is equal to ABC, D, ABC. Delete all the letters. Hmm. So I have the opportunity to delete the entire string. So this won't take like 1, 2, 3, 4, 5, 6, 7 operations, but I can delete this in one operation. So that's why I thought why it's 2. So ABC got deleted because I have a following ABC pattern here. But like this thing has no pattern in there, so I can probably delete all of them. There could be a little trick here as well, that what if this had a AB here, right? But this has no AB in front. In that case, I know what will happen. Uh, so in this case, A got deleted once, then A got deleted once. Now I have A, B, A, B. So that's 3 operations, right? But it's saying 4. So delete the first letter A since the letter oh is equal, since the next letter is equal. So A got deleted. Now S becomes this. So I can probably go for A, B deletion. Delete the first 3 letters. Yes, done. Oh, okay. Hmm. Now S becomes this. So now AAB has a pattern that A is repeating. So okay, the next letter is equal. Now S is becoming AB, and then both of them that gets deleted at once. So it's saying return the maximum number of operations, right? So even if I have like um let's say I had the value AAB, then in that case it's saying maximum number of operations, right? So to get a maximum number of operations, I could possibly do this. That first way is that okay, delete AAB, that's 1. Delete AA, then AB at once. So answer is 3. But I could also do that, okay, delete A because this A is kind of matching. So that's one operation. Now I have this left. Here I can say that okay, delete this entire thing. So that's one operation. So 2 of them. So what is the end thing I can see here? That at a certain point I can maybe delete or maybe not delete, right? But how do I actually determine that? So in here I could probably say that hey, um, I'm at this index and I have the value A, so check if the next value is same. Yeah, it is same. So maybe try to delete it. So delete operation 1 plus this entire string, I'll apply the same operation. But on this entire string I know I'll get only 1, so that's it. Like that's the end of the day. Now other thing I could do is that okay, at this point don't uh, consider deleting this A, check further. So I go here and then start checking further. So I see again this AA, and this is not never going to match the pattern. So in this case, I again go forward and go here, right? By the way, if it's not matching the pattern, then I return back 1. But if it's matching the pattern, then go forward, right? I think so it's more like in here, it was matching the pattern. So I can be like, okay, go forward and delete. Or I could say that, okay, let's consider this as a whole. So I'm saying that, okay, continue. But here also, if I go forward and delete this, then I have to deal with A, B, A, B. And then again, here I have the options. What if I had one more A and then so on. Something like this is also given like this. So in this case too, like it could be very simple. Delete this, this. That's 5 operations. Okay, so you can see where I am heading to. So what I can say is, let's create a function solve, which is going to take a little bit of things here and there. So result is going to be, or what can I say, possibly max operations is going to be something which I get from the solve function, and then I'll return the max number of operations. So in solve, I'll probably have the very first index in S. I'll have the S itself. Length of S is something I think so I don't need really. Yeah, I don't really need that. Um, that's it, right? So uh, oh yeah, so that's S, right? And I need to have a running sum or a running string, right? Which in my case initially would be S of IDX, if I'm not wrong, which is S of 0. So I can say my current string. There's something I need to have, current string. So in this case, I'll say that, okay, or current string would be empty, right? At the very beginning. Yeah. So take the current value into consideration. So that would be current string plus equivalent to S of IDX. Now check if the current string is following the pattern or not. So let's say last IDX would be what? It would be probably length of the current string, but that's not enough. I'll say IDX plus length of current string. So let's say IDX is at 1 and I have considered 0 and 1. So 1 plus 2 is 3. 2, 3 plus 1 will be there. That's it. Now I will probably say let's get rid of that. So I can say probably that, okay, if my last IDX is less than length of the original string S, in that case if the last index is less than the length of string S, then in that case check if it's valid or check if it's not valid. So if I check for validity, that is very simple. If s of, or I can probably say if my current string is equivalent to s of uh, from idx plus 1 till last idx plus 1, because see what this is what's happening. So let's say my idx is here 0 1 2 3 4 5. So if this is here, then I need to check these two elements, right? These two elements I need to check. So how do I get this index? That's going to be 1 plus this length 3. Now since this is like 3, so 0 1 2 3, so how do I get this? So I say idx plus 1 here till that, that's fine. So if that's equal, in that case I can probably say that my way 1 is 0 and let's say way 2 is also 0. Yeah, in this case I can say that okay, way 1 is equal to one deletion of this thing plus solve call at idx plus 1 definitely, or I think so I need to call at last idx plus 1 definitely, and then s will be followed with current string being empty, right? Because this was a match. But like my way to would be simply I'm not deleting this thing and then solve of probably what's the time, 9:24. Okay, idx plus 1, and then s will be same as it is and my current string will be what it is, right? And then I can probably return the maximum of my way 1 and way 2. Also I need to have a little base case going on here because this is going to go out of bounds. So I can say that okay, if my index reaches the length of s, or if it's probably greater than length of s, in that case return 0, or return negative float infinity. That could probably make sense. Oh no, I can return 0, right? Also there is one thing to consider here, that this way 2 could be inside this, um, like literally inside this, and in the else part I could have return 0 because, or return 1 because I'm deleting the entire string in one go. Hmm. And also like this way 1 and way 2 could be paired up outside. That will make a lot of sense. Let's try our luck here. It's giving me 1, which is absolutely wrong. It should be 2. What if this is 1? So initially current string becomes what? A, right? Okay, let's use this test case wherein we have a bunch of things. So this is going to give me the answer 3, right? It's giving me 1 again. I think so. This is the problem here, right? And let's stick to the previous version with 0. Oh, okay, okay. So, okay, so this S is going to change, right? Oh my God. So this is going to be IDX plus 1. Beautiful. And then this is going to get reset to 0. That's what I was thinking. Yes, and this is going to be last IDX plus 1. Done, done, done. And this is going to be empty. But if I'm not taking it, then S is as it is, what it was, and current string will be whatever it is. I hope so. This is the thing here. It's giving me 1 again. There's something wrong which I've done here. Excuse me. So initially A is being taken in current string, and then last index is going to be 0 plus 1. So 1. If 1 is less than the length of S, which it is, then if current string, which is A, is equal to S of 1, and that thing, yeah, in that case V1 is 1 plus solve of 0, last index plus 1 I'm calling, right? So I think so this should be called with IDX plus 1. No. Well, this was 1. It's still that thing. Okay, I will solve this later. Can't think of right now anything. End broadcast.